Action. All right. Well, thank you for coming this evening. My name is Martin Guerena. As the slide says, I'm the IPM coordinator for the city of Davis. And you might ask, well, what does the IPM coordinator do? I work with parks and public works, and they're mostly weed abatement. 99% of the pests that we deal with here are weeds. In the parks, of course, you see the landscaping and lawns and stuff that we have weeds in. But in public works, there's stuff that you might not be aware of, like roadside maintenance, ditches, drainage, the storm drain, the wastewater treatment plant, the wetlands, there's about 500 acres over there. And open space, also another 500 acres, the South Fork Preserve, the Wild Horse Ag Buffer, and the Cerro Ag Buffer, etc. So there's quite a bit of activity going on. And I think it was more like in the 90s or so the position first came up. It was filled for a while and then dropped. The lady that was here left and wasn't filled in until 2007 when I came in. So that's what, 8 years? Close to 8 years. So primarily my job is, and people say, well, he's a pesticide guy. But no, it's on the contrary. I try to reduce pesticides and look at alternatives. Of course, pesticides are the last resort in IPM, and we've been trying to choose the less toxic alternatives, the quote, less dangerous ones, both as far as pollution and especially in parks, exposure. So that's a big issue here, and citizens are concerned about that, and basically that's what I do. My previous life, I worked in agriculture, and that's how you get trained in this kind of thing. Although there's some urban professionals that have done that, mostly the pest control, the termite people and things like that, but most of the jobs and my training and stuff was geared in ag. And I did work in organic ag for a while, so I got to learn a lot of techniques there that at the time in the 90s, you say, oh, it's just a fad and it's a passing thing, but now you can see it, it's pretty driven factor, and it's mostly consumer driven. Just like a lot of this stuff we'll be talking about here. But mostly for gardeners, I assume, you have small areas of land, but it could also be applied on a larger scale, and that's where I'm coming from. So this is the official definition of what IPM is according to UC. There's hundreds of definitions, but it's the process where you can solve a pest problem while minimizing risk to people and the environment. IPM can be used to manage all kinds of pests anywhere in urban, ag, and wildlands and natural areas. The minimizing pest, people right away think, or minimizing risk, people right away think, well, pesticides, but a lot of times a pest is more of a threat than the actual pesticide, in the case of mosquitoes and diseases and so forth, so just keep that in mind. This graphic here, picture's worth 1,000 words. I like it because it kind of visualizes what we talk about. The pyramid here, the IPM pyramid I call, the bottom, the base, the foundation of it all are what we call cultural practices. And in agriculture, well, same in gardening. Your site selection, what kind of plants you're gonna grow, sanitation, pruning, rotation is considered a cultural practice. Then you move up the tier to physical, mechanical controls. Simple example is weeding, hoeing. That's a mechanical control. Pruning diseased limbs off your tree or in your vegetable garden, etc. Barriers, insect traps, and so forth. Then the next tier, biological. And here we're dealing with organisms to control other organisms. And usually in gardening, it's attracting natural predators into your garden. Have them take care of the aphids rather than you spraying something on there. Ladybugs, lacewings, and we'll go over those too, and you can see the different stages of growth and so forth. Then the final tier, chemical, and we have it divided into two. The lower tier of the chemicals are what I would consider the less toxic ones, such as oils and soaps, baking soda, repellents, insect growth regulators, microbials, which could fall into biological also. And then conventional just kill on contact, well, that's no longer the case. You know, a lot of the stuff's kind of resistant, and it's more of, I would say it's petrochemical-based pesticides. And as you can see on these arrows, you start off with prevention on the bottom, you know, proactive up to reactive and intervention. And toxicity, of course, increases as you go up the tier. And feel free to interrupt and ask questions as I go, because I'll be covering first, I'm going to get into soils, because I think that's the basis of plant health. And then we'll look at insects, diseases, weeds, and vertebrate pests. And if we have time, we can dive into household pests, I guess. So these principles are basically what guides an IPM program. First off is knowing what you're dealing with, pest ID. You know, people, I get calls sometimes, oh, I got spots on my plant. Or, for example, powdery mildew versus downy mildew, two completely different organisms, although they look the same, and the treatments are very different. Insects also look a lot alike and so forth, but you got to make sure you nail it and you know what you're dealing with. Monitoring, assessing the pest numbers and damage, and guidelines when management action is needed. They're kind of related. It's known as the action threshold. When there's enough of a pest to cause a problem, to cause economic damage or reduction in yields and so forth that warrant you going out there and doing something about it. Preventing pest problems, a lot of the cultural practices is intended to do that. And then combining cultural, biological, physical, chemical to do the job. But pest ID, I think, is the most important thing. Pest management is based on soil health. When I was in organic ag, it was like you feed the soil and the soil will take care of the plants. And that's basically it. Recently, there's been a lot of, I wouldn't say discoveries, but yeah, discoveries of soil, microbe, plant interaction that were not known before and are very specialized, and it's still a broadening field. So healthy soils feed and nurture the plant. Diverse soils contain many beneficial organisms that compete with pests in the case of like plant diseases and stuff, but also trigger the plant's immune system to resist or tolerate pests. Here you see this picture, and I'll show it again later on, but the orange are mostly roots, but any idea what this white stuff is here? Yeah, mushroom, mycelium. Well, mycorrhiza, I mean, which is a symbiote, lives in coordination with the plant, and actually you can see how it extends the root zone. And nutrient absorption, water absorption, also there's a deeper relationship as far as phytochemicals and signals and so forth. Communication between plants, we've heard about, actually this entomologist spoke recently at UCD about talking plants. And I remember there was this book back in the 70s, Secret Life of Plants, which was a little ridiculous. But in reality, he had something going. So, does good soil management equal good pest management? Yes. Not all soils are the same, of course. There's different textures and conditions. Here in Davis, we have YOLO loam. Kind of a sticky, depending. I've been burying compost in my backyard, well, for the close to 10 years I've been living in East Davis. And now what I do is I put a hole down and put my week's worth of kitchen waste and then move on to the next spot and so forth. By the sixth time around, I make the circle, and it's totally broken down full of worms. But I've been doing this all over the garden, and now I go in and dig, And it's very, we call it friable. There's good tilth. You can actually go in there. It's not as sticky, and you see all the earthworms and organic matter, and it's just wonderful. Yes?
That was brought up at a Master Gardener's meeting the other day.
Yes.
One concern what the Master Gardeners mentioned was viruses, or carrying viruses by doing that technique. Is that...
In the kitchen waste?
Yeah.
I think it's...
Meat or...
No, plant diseases. Plant diseases. Unlikely. Because I think once it's down in the ground and we'll look at the different microbial breakdown and stuff. I doubt that many viruses would be able to survive. Yeah. So there's two phenomena, one known as systemic acquired resistance. And that is when, for example, an insect or a pathogen is attacking a plant. The plant provides resistance by releasing or increasing what is known as salicylic acid. Do you guys know what that is? Common name? Aspirin. Now, have you guys ever put roses, vase and aspirin in the rose to prevent botrytis? Is usually that disease that kind of affects the rose and the head wilts down like so forth. That affects the vascular system. Well, that could be a response or something to keep it going. Now be careful though, because too much aspirin can also be toxic to the plant. So there's a fine line. But this is produced in the plant through the roots in the soil. Microbes stimulate the plants above ground to produce this hormone and therefore resist plant attack. The other one is jasmonic acid. And ethylene and they call it jasmonite, increase through all the plants, also when they're being attacked either by insects or plant diseases. So you have plant growth promoting rhizobacteria stimulates plant growth and activate this immune system, if you will. And this is induced systemic resistance. So there is some truth to this. This was last year, I think the New York Times ran an article as well as the Atlantic. And it talked about soil microbes and the new Brave New World and research and everything that's supposedly going on there. And they had this example here, which is a little complicated, but it's fascinating if you follow me a little bit. Here we have, can't see the writing too well, it's known as Alternaria blight or Pseudomonas syringae. And what it does, of course, it invades the plant, but usually through stomata. And it goes into the plant, and it's a bacteria and causes what is known as a leaf spot, bacterial leaf spot. So what happens is, as a result, the roots respond and produce malic acid. And that, in response, triggers or stimulates this beneficial bacteria known as Bacillus subtilis. And this was discovered, well, it was known for a while, but it was kind of bottled and canned, if you will, and sold as a pesticide recently by Marone Bioorganics here in town. And it's one of the big, Sonata, I think the name is. But anyhow, the tomato plant releases lactic acid and it stimulates the Bacillus subtilis, and what did it say? It produces antimicrobial defense, eliminating potential to colonize the roots. This in turn produces abscisic acid, okay, which closes the stomata, preventing further infection. Now, you have this other tomato disease, Alternaria solani, and that's a bacterial disease. Spore lands on the leaf plant. So what happens, you have new infection of this Alternaria, or tomato leaf spot, fungus. And the other plants are signaled by that mycorrhiza that's connected from root to root, signaling a potential attack, which is just fascinating. They do talk to each other, telling them, hey. Other phenomena is, for example, an insect chewing on a plant and the plant releasing phytochemicals into the air, which the predator or the parasite of that pest pick up on and figure, oh, here's my host. Not that they focus indirectly on the insect, but the reaction of the plant being attacked by this host. So there's so many things that are intertwined there, especially in the soil, and we'll talk more about the soil. The problem is, of course, we step on soil. We can't like cut a profile and look at all these wonderful things happening. And most of these things are microscopic too, so it's difficult to see, but they exist. Back in the early 2000s, the soil food web was a big thing, and it's basically what this is, different trophic levels within the soil ecosystem, which is divided into higher organisms that feed on the smaller ones and so forth. But what drives it all? Organic matter. So compost, cover crops, organic fertilizers are the way to go. I went to school here at UCD, was plant science major, and I remember them telling me, oh, chemical nitrogen is no different than the organic nitrogen. It's all the same. Well, yeah, the actual element. The problem with chemical fertilizers is you use too much. Most of it gets leached out, and then whatever's taken up by the plant, it just hypes them up and makes them really grow, uncontrollably. Well, this is also a signal to pests, to insects and diseases. Hey, we have too much nitrogen here. Come and get it. So, this was a Soil Conservation Service, which is now the Resource Conservation Service, an old poster about forestry. That's the same. It says 1 gram of ag soil contains 100 million to 1 billion individual bacteria. Several yards of fungi, the mycelium, the little white thread. Close to 1,000 protozoa. 10 to 12 bacteria, feeding nematodes, few fungi, and predatory. Then 1 square foot of ag will have arthropods and earthworms, depending on how rich in organic matter that is. But that gives you an idea of the amount of biomass in there, the activity that goes on. Very, very complicated and integrated. So who are the players? I'll go quickly through this. Photosynthesizers. First level, they're like plants, but they're down on the ground. If you tend to over-irrigate a little bit, you'll see a little algae growing at the base of the plant. They're in the soil. They're just waiting for the right conditions. These guys capture solar energy, fix nitrogen, add organic matter to the soil. Your decomposers, bacteria, fungi, they retain nutrients in their biomass. They create organic compounds, sources of energy and nutrients for other organisms through excretions and exudates, enzymes, organic acids. It's just fascinating. They produce compounds that bind the soil into aggregates. Soil quality is very important here. And they convert forms of nitrogen, nitrifying or denitrifying depending on the conditions. They compete or inhibit disease-causing organisms. One of those is actinomycetes. It's a major component of soils. It's actually a bacteria, but it kind of looks like a fungi because it grows segmented kind of hyphae. But it's actually a bacteria that's just connected to each other. But this is what gives soil the distinct smell, like after a rain. Just quickly, after the other fungi and bacteria have broken stuff down, they go for the cellulose, the heavy stuff, and continue the breakdown. They're responsible for humus in the soil, the musky order. But what's interesting is a lot of the organisms under this genus are antibiotics. Streptomycetes, actinomycetes, terramycin. So what does that do as far as disease or disease protection against the plant? Also, you've heard, and I got a slide of that too, that working in the soil and you smelling soil kind of relieves depression, makes you happier, feel good. As gardeners, I'm sure you've experienced that. But it's due to the soil. or the microbes in the soil. Other important bacteria, of course, the nitrogen fixers, the denitrifying bacteria, and the nitrifying bacteria. They're all players in this. There we go. Exposure to soil bacteria, Mycobacterium vaccae, is like a natural antidepressant, activating brain cells that improve mood, reduce anxiety, and facilitate learning. So here's a picture of just fungi, of mycelium and different fungi and bacteria. So you have your mutualists, the symbiotes, the mycorrhizal I was talking about, nitrogen-fixing bacteria. They're all part of this system. Two types of mycelium, endomycorrhiza and ectomycorrhiza. Of course, one meaning inside and the other one outside. The ecto will invade the plant, but not necessarily break into the cell, but just occupy the intercellular space and leave all the cells intact. Whereas the endomycorrhiza will invade a few cells, but leave most of them alone, enough that the plant doesn't suffer from it, actually benefits from the effect of a larger root zone, let's say, absorption, water, nutrients, etc. Here's some pictures of it. Something like 75% of all plant species have this type of fungi associated with them. Brassicas, one of our most common vegetables, do not. We grow cabbage, broccoli, cauliflower. Well, they don't have mycorrhiza fungi associated with it. But like I said, 75% of all plants have this association. And there's others besides this. So, of course, you have your bad guys that are there too, just because, you know, you need them. We do need them. Plant-feeding nematodes, other type of diseases. Insects, you know, you have your grubs and lawns. These guys are pretty bad. But there's, you know, enemies, natural enemies for them. One of them being Sternonema, a nematode that will sting them. But sting isn't what kills them. It's a sac of pathogenic bacteria to the insect that's injected into the system and eventually kills the grub. It's a dog-eat-dog world in there. You have fungi that prey on nematodes. Now, they don't distinguish good or bad. Whatever goes, it's like a little noose. Here's a bigger picture of it. And they swim in there and they slip in. As soon as it's stimulated and feels it, it squeezes the noose and sucks all the nutrients and juices and everything. And you know, all these science fiction writers, horror movies and stuff, all their inspiration is through entomology and nematology. Grazers, bacteria feeders, protozoa, nematodes. You notice this nematode here opens up like a funnel and just goes swimming and sucking up whatever it can find. And fungal feeders, they release available nitrogen. So all these, this drama of life. Of course, you have life and death and so forth. So during the death period, there's releasing nutrients to the plant. I remember also some soil scientists saying that a lot of times they would analyze roots and determine, well, this is deficient in, you know, calcium or iron or so forth. But in reality, these systems are so tight that a lot of those nutrients are in these organisms, and there's very little leakage, if you will, from the root zone to be able to detect this in, let's say, an analysis. And then your higher level up shredders, your earthworms, macroarthropods, little springtails and false scorpions and stuff. Shred plant litter, they burrow in through the soil, help with aeration and enhance soil structure and so forth. So organic matter fuels all this, either through compost, cover crops, crop rotation, and of course organic fertilizers, which are not cheap, but can achieve that. With vegetables, for example, when I worked in an organic farm, we're talking, hundreds of acres. They would need to go in halfway through the season to supplement some nutrients with organic fertilizers. But it was treated just like a conventional farm would do the same, except with chemical fertilizers. So besides soil nutrients and stuff, right now we're talking drought. Organic matter is like a sponge. It absorbs water and retains it. There's a great picture from Rodell Institute in Pennsylvania where they were dry farming organic and then the conventional farmer right next to them, and they both planted corn, and they went through years of drought there, and you can see the corn in the organic that was a foot or two higher, looked a lot better than the conventional one that was next door. The only difference was one was farmed organically and the other one conventionally. But there's minerals, there's pores, pore space that's filled in with either water or air. So organic matter helps to retain some of that moisture. Glomalin, fungi, soil aggregates, it helps with the aggregation with the soil. Instead of it being silty and either blowing away or washing away with water eroding away, it kind of clumps together and holds its form a lot easier. And it also helps with soil water penetration. You can see when there isn't enough organic matter stuff, you'll have real silty soil that usually seal up and you have more runoff rather than percolation and infiltration. So if you guys want to read more on this, NRC webpage, this is kind of old, but if you Google soil biology primer or Elaine Ingram's soil food web, that tomato disease interaction was an article from Nature 2012. And there's more and more, like I said, discoveries as far as soil microbes and plants. So we looked at the soil, but above ground there's also a food web, and we know that the big bug eats the smaller bug, and the bird eats the big bug, and the hawk will eat the other bird, and so forth, and the chain of life continues. So diversity we're talking here in the garden also contributes to plant health. This is at the community gardens, which Jane, by the way, is the coordinator there. And this is this gentleman, he has a second plot up against the school district.
The second plot from the street?
Yeah.
Oh, yeah, that's Quinn.
Yes. This, I walk by through there quite a bit. Well, actually, I'm in charge of the gardens too. But I walk by there quite a bit. And this garden in the winter amazed me. Well, in the fall, I noticed he still had stuff from the summer, and then once the fall came in, he had stuff growing everywhere. I mean, at the base of plants here, he has azaleas, garlic or onions, and here's some flowering onions, and all the leafy vegetables, lettuces and stuff right now. But he had stuff growing in every imaginable place, so he was always harvesting and getting stuff, and they looked healthy as can be. I didn't see any worm damage, any bug damage, because I mean, if you're a bug and you're looking for your host, you have a harder time finding it there than, let's say, a nice row of lettuce, or a big patch of broccoli.
He had bok choy in the summer last year.
Oh.
I had given him some seed
Mm-hmm.
from the last winter's crop. He just planted it right away in a little shady spot.
Yeah.
And he was harvesting it way before people were planting their fall crops.
Yeah, that's great. Yeah, very resourceful, and like I said, make the use of all that space, the little space that he has. So habitat needed for beneficial insects. Overwintering, nesting, shelter, water, nectar, pollen, alternate hosts, alternate prey. Usually we expect them to come in, but if you provide some habitat in the form of pollen or nectar source, and it doesn't have to be, huge plants, but if you can, add some color to your garden with some flowers or shrubs, or actually at the edge of your yard with natives, that require very little water. They're great sources of prey. Here we're talking about California native insectary plants. This is more in agriculture, but you look at the flowering periods of California natives, and they're basically flowering, producing pollen and nectar year round. You just got to have the right combination in order to have that the whole time. And you guys could probably Google this too and find it. Talking willow, ceanothus, coffeeberry. These are huge shrubs, but smaller flowering plants like yarrow. Buckwheat, I put some buckwheat in my yard. It started out this big. It's low-lying, but now it's a huge circle in my yard. So it's filling in space, and that's part of my killing my lawn process, is putting some of these guys in there. Queen St. Catherine's lace, milkweed. Besides providing habitat for these predatory insects, we're talking pollinators also. That's very critical. People talk about the honeybee collapsing, and yeah, that's happening, but the native bees are also suffering, and more so if not, because they're being exposed to the same issues that the honeybees are. So beneficial insects, they provide a benefit to agricultural production, such as natural enemies, pollinators, and I included silkworm. We make silk out of them. Somebody tried to start a silk industry here in California, and as a result, I think the gypsy moth was the pest. It became a pest. It didn't work too much. We got gypsy moth out of California now. It's, I think, east of the Rockies. But so you got to be careful what you do when you're bringing in exotic species.
Is that a lacewing or what is that?
A honeybee, this is a damsel bug, killing off a nice size bug. There's another, assassin bugs are the same. They have a proboscis, and they'll just pierce and suck the juice out of a plant. So we talked about insect ID, and we all know what a ladybug is, but a lot of people don't know what the larva or the pupa look like. Same thing with Syrphid Fly. When I was working in organic ag, one of the contract farmers we had, a Mexican guy, great farmer, but he had aphids, and we were starting the organic thing in the 90s, and he found a bunch of these little green worms, and it was like, I tried spraying BT on them and stuff. Well, fortunately, BT will not affect them. Bacillus thuringiensis, it only affects Lepidoptera. This is a Diptera. It's a maggot, but it's a predator, and it eats aphids. It's the larva of the hoverfly. You've seen those around. They kind of look like bees and kind of just like move around. Well, they lay little eggs, and then you have these little maggots that come up and just start eating away at aphids, and then they pupate, and out comes the mature fly. Lacewing larvae, the same. Lacewings, there's a few species that are carnivorous as adults, but most of them that we find here, they're pollen and nectar feeders. Their offspring, their larvae, are the predators. And they're so ferocious that they had to, nature developed a way for the female to lay an egg and first do this little thread type hair and put the egg on top of it. So when the siblings are born together, they don't eat each other. They have to climb down, and they're starting looking for prey rather than going up the stalk and eating their brother or sister. But you can see they got these mandibles up front, and that's how they feel themselves around, and if they can puncture it, the juice, it's kind of like this blade with a groove in it, and whatever they puncture, the juice just pours down right into their mouth. So aphids, of course, one of their favorite foods are just these little sacs of protoplasm there that. So knowing the larvae, the eggs, and so forth is very important. Here's the list of general predators naturally occurring here in California. Assassin bug, like I mentioned, big-eyed bug, brown lacewings, similar to green lacewings, except they're brown, and they lay their eggs not on a stalk but individually. And I found them a lot in celery fields. They would go down into the heart of the celery because there were aphids in there. But you have damsel bugs also, green lacewings, minute pirate bugs, striped collops beetle. I found those a lot here in my plum tree. When I get aphids, they're little, well, about an inch with solid wings, leathery type wings in the back. And first I thought it was a pest, but then I noticed they were eating, then I identified it as a collops beetle. And spiders, unsung heroes. People have the EBGBs about spiders, you know, black widows, ooh, brown recluse, ooh. But no, most of them are good. Even those guys eat bugs. They don't want to bite you. Although people stick their hands in dark areas and, and tool sheds.
I have a big old gray mantis in my yard, and I think it's killed a couple of black widows.
Oh yeah, sure. Beneficials will kill other beneficials too. They don't discriminate. Whatever comes across, they're opportunists. The problem with praying mantis, and everybody talks about, you know, they're big and they only catch, you know, other big size insects, and that's about it. The big problem are the tiny little insects, the aphids, the spider mites that just reproduce exponentially and overcome and weaken a plant. Not that praying mantises aren't, you know, they have a role, but yeah.
Babies probably get them.
Yeah, there's little babies, right? So here's a big-eyed bug eating a cluster of eggs, and they have a proboscis there, and they pierce and suck the juice right out of them and go through and do that. The ladybug, you see the larva there, and the roses. They look like little alligators, if you will. Same thing, they have chewing mouth parts, and they'll just go around. I've seen the cluster of eggs. They're usually in a group, those little orange ones. Ladybug eggs. Syrphid fly, I talked about those. They look like worms, but they're predatory worms and mostly active during the summer. And here's one on a lettuce leaf going for an aphid. Green lacewings, you can see they take down a worm that's, you know, 3/4 as big as he. So all soft-bodied insects, they don't discriminate. They'll eat damsel bugs. Found more, once it warms up a bit here, they're found a lot in alfalfa. Alfalfa, if you ever have a bug net and you want to collect insects, is a great place for them because you'll get all types, pests, predators, worms, you name it. It's in an alfalfa field. And you can see the nymph there is attacking a pretty sized big bug. And a lygus bug, which is a terrible pest here, it pierces and sucks growing points and fruits and ruins a bunch of stuff. And a lot of pesticides are used to control it, but you know, he takes them down and makes a meal out of them. Minute pirate bug, it looks kind of like a pirate flag with crossbones in the back. But you can see it here, eating a small worm also. The proboscis comes, punctures it, and sucks all the juice out. The eggs are underneath, usually in the vein of the leaf. And the nymphs, you know, look nothing like them, but they're predatory also. Whoops. Oh, here, let's get rid of this. Okay. Whoops. And like I said, spiders. Wolf spiders don't spin webs, but you've seen them up on the screen when a fly comes and they kind of wait, and they'll just shoot right after it and grab the fly before it takes off. And then a crab spider, same thing. It kind of camouflaged here so a pollinator will come and visit the flower and it'll just come up and grab them. And then the web spinners, and then the ones that eat people. Bats. People also get the EBGBs about bats. Oh no, rabies, oh my God, no, vampires, oh no. Under the Covell Bridge here, there's a colony. They're probably already there now. If you ever drive by there, of course, don't slow down and look, but just, you'll feel the bump as you go right under there. And that's been years and years of bat guano just falling on the pavement and creating a little hole there, basically. So next time you go, and of course the yellow bypass, millions of them, and I've been out there at dusk, and you just see these clouds going out, and what do they go and eat? Insects, mosquitoes, moths, which are nocturnal, big pests in agriculture. So they're